Hello all, welcome to the post-contest discussion video of Leetcode Biweekly 154 contest. So today with me I have Ishan Kulkarni. Hi Ishan. So let's start the video. Let's discuss the first problem. So the question is minimum operations to make array sum divisible by k. So you are given an array nums and an integer k, and you can perform a following operation any number of times on that array. What is the operation? Select any index I and replace nums I with nums of I minus 1. That is like just subtract 1 from that number, and you have to return the minimum number of operations required to make the sum of array divisible by k. What you can do is, like, in one operation we can uh, reduce the element by 1, and that is one operation we can do, and we have to figure out like how much uh, how much minimum operations we can make the array sum divisible by k. So, like, it's a very easy question. What we can do, just we can just calculate the sum of array, and whichever is the remainder, whatever is the remainder on dividing with k by of that sum, that is the answer. So yeah, we have done the same thing here. We are, like, for example, if we take the test case here, 7 plus 9 is 16, and 16 plus 3 is how much? 19. And if we modulo 19 with 5, we will get remainder as 4. So the minimum operations we will require will be 4. So we have done the same thing here. We have calculated the sum of the array, and then we are returning sum modulo k as the answer. Okay, yeah. Now let's see the second question. So second question, yeah, number of XOR triplets when. Okay, so Ishan, in the second question we are given with array nums. Again, we are given with an array, and it is the special thing about that array is it is a permutation. What does a permutation means? Like, the numbers which will be in that array, they all will be between 1 to n only. Okay, their order can be different, but n is the length of array. Yeah, their orders can be different, but the numbers will be in the range from 1 to n only. Yeah. Now, what in the question, what we can do is, we have to do XOR triplet. What does XOR triplet means? You have to do nums I XOR nums j XOR nums k. So we can do the XOR of three elements, and those three elements can be uh, have to be from that array. Okay, and they can be same also and different also. Okay, that, what does that means? So, like, if we take this array, so we can XOR 1 XOR 1 XOR 1 means, like, we have taken three elements together, and we are XORing all them. Other thing what we can do is, we can take 2 times 1 and 1 time 2, and then do the XOR. Other thing can we do is, like, taking 2 times 2 and 1 times 1. And yeah, last option what we can do is taking all the twos. So yes, we can make triplets anyhow, like in all combinations, and yeah, we have to do XOR of it. Now at the last, what we have to return is return the unique number of XOR triplets values from all possible ijk pairs, all, like, yeah. So here, for this array, there are only four possible XOR triplets, and but the XOR, like, unique XOR, the output which is coming, that is only two. Like, we can see that 1 XOR 1 is coming 1, and 1 XOR 1 XOR 2 is coming 2. And if we do XOR of other three pairs also, other two triplets also, then also it's coming 1 and 2 only. So the answer will be 2 here, because only two unique answers we are getting here. And yeah, we can see the same thing for here. But now, if we have to apply brute force here, so the time complexity will be around n cube, because we are trying to make triplets. Okay, so obviously it will be n cube, and it will not work because it's 10 raised to 5. So yeah, so solve this in big of n. Let's take an example and understand the question. Yeah, so, like, if we take the example of an array 1, 2, 3, 4, 5. Yeah, let's take only 5. Yes, and if we write the binary representation of all those elements, so it will be 001 001 and 010 011, that is 3, and then 100 it's 4, and next is 5101. Now yes, so we all these elements are there. Now we always know that if we do 3 times XOR of the same number, we will get the number again, because like if we take example here 1 of 1, if we do 1 XOR 1, it will get neutralized, okay, and it will give us 0, and then we are doing XOR of 0 to 1, and it will give the number itself. That's why so what's the observation here, that all the numbers will come in the XOR. Like what we can do is we can do 3 times 1 3 times, so we will get the output 1. Then we can do 3 times 2, same like till 5. So definitely we are getting all the elements from 1 to 5 uh, as an output. So 5 is the like answer, it is for sure, and now we have to find out what more answers can we get. So if we observe, the highest number here is 5, okay, and the highest possible bits, like uh, if if we have to form any number, like if we are doing XOR, so all we have to, if we have to find the highest possible number by making an XOR, that will be like making all the bits 1. So it will be how much, it will be like triple 1, okay. So uh, we have to just see that can we make uh, the numbers, yeah, that is the highest number. So just a second. Yeah, so like we can generate all the numbers before this thing, the next power of 2. Like so if the answer is like not answer, the length of array is 5, so the next power of 2 is how much, it's 8. So 8 minus 1, 7. So we can generate all the numbers before 7. So from 1 to 7 we can generate all the numbers, and also we can generate 0. um, how can we generate 0? So in the case like second test case, we can see that we are doing 3 XOR 1 XOR 2. So if like in that case we are getting 0. So for all the length, all the ends which is greater than 2, like which is greater less than equal, sorry, greater than equal to 3, then you have the 0 will be in the answer. But for like less than equal to 2, 0 will not be in the answer. That's why it's a base case type thing. Yeah, so for the code for it will be, so it was a simple observation question of bitwise. So the code for it is like base case, first if less than 2 equal to 2, just return the length of array, and then I am calculating the next power of uh, next to the power of n, okay, after n. Yeah, so for that I have just taken like traversed the, I am just iterating through that number, and I am doing right shift again and again, and trying to calculate the power of 2 which will be next after n, and then I am just returning it as an answer. Okay, so this was the second question. Let's see the third question. Now the third question was the second part of this question. In this you are given an, again same question, you are given an array, but the only difference in this question is that the array will not be a permutation. So there can be any numbers, any number in the entire array. There is not a specific range. In the previous question there was like only the array will be from uh, 1 to array dot length, but now here the array can be the elements of array can be of any number. Okay, but yes, the constraints of this question is less, it's 1500, so n square will work here. Yeah, so the approach for this question was not similar to obviously previous, because the previous one was just an observation. So what I did was, like if we try to do brute force in this, then obviously we have to do it in n cube. uh, So instead what I tried, actually if we see the constraint, the nums dot length, like the length of the array is also 1500, and the values in the array is also less than equal to 1500. So if uh, the largest element is 1500, okay, uh, so the largest XOR possible, we have to, if we think what is the largest XOR possible, so it will not like more than, definitely not more than 10,000. Okay, it will be actually lesser than 10,000, because the bitwise, what is the bitwise representation of uh, 1500, Ishan? Do you know? Can you search it?
1500 bitwise.
Yeah. And next,
10 1
1 0 triple 1
0 0
0 0
1 1
1 1
0 0.
0 0. Okay, and then what, then the next power of 2 minus 1, what will be, what it will be, it will be like all ones. Okay, all ones, so all ones, right? Yes, all ones. So what it will be, 1 2 3 4 5 6 7 8 9 10 11, 2 to the power uh, 11,
10
actually it will be how much,
times
2048. 2048. So maximum, the like maximum answer can be only 2048. Okay, so what we can do is, first we can, like we have to do triplet, but what if we first do pairwise, like we just do pairwise XOR of every element. Okay, and then obviously it will be less than 2048. So I have make I have made an array which is of 10,000 length. It actually don't need to be 10,000, but yeah, it is of 10,000 length. And what I am doing is I am just doing pairwise bitwise XOR of all the values. So this will take n square. Okay, and what I am doing is I am just marking array of that, like answer, what whichever is coming, nums I XOR nums j, I am just marking it as -1, representing that that value exists. And then again what I am doing is I am traversing to the array, and then again I am doing bitwise XOR of all the elements which have been as the output of XOR for the for what, for the previous pairwise XORs. Okay, so that is stored in this array, and so the whichever element is having the value -1, that means there is a pairwise XOR of that value, and then I am just doing XOR of that number with all the numbers again, and then I am adding that in set. Okay, and at last what I am doing is adding the element itself also in the set, uh, because as we know that uh, definitely the self element will be in the answer. So for time complexity of this question, this is n into n, and this is also n into n, n into n, and this is n. Yeah, so it's 2 into n square plus yeah, n. So this is the time complexity of this and at last I am returning the set size, so it will only store unique elements and it will return. Yes, so this was the third question. Now क्या हो गया भाई? Yeah, wait, so there was a silly mistake here. Yes, so this was the third question. Now let's move on to uh, fourth question. So fourth question, yeah, it fourth question will be explained by Ishan. So just a second, I will get your code, Ishan. Yeah, this is your code, CPP code. Okay, over to you,
Yes,
Ishan. Hmm.
yes, yes. So, In this question, we are given a weighted tree. Each edge has a weight associated with it, and they have given edges
Just a
array
second,
and
Ishan.
all that.
Fine, now fine.
They,
You can say.
and we have given queries 2D vector. In each, there are two types of queries. In one query, we are changing the edge weight to w dash, and in another query we have to compute the shortest path from the root. That is, here it is, here the tree is rooted at node 1, and to node x we have to find the shortest path. So I think the question is clear,
Yes,
and the main thing, the most simple thing is that there is no shortest path basically. Means
in
in
tree.
tree there is only
Yes,
one
right.
unique path, so we don't have to consider that.
Shortest
So
path.
before, yes. So before approaching the question, you should know the concepts of Euler tour and segmentary.
Segmentary.
You can,
Yes, and Ishan, just to add more about this question, so you are given obviously a tree, and then uh, uh, obviously a tree and in the form of edges, and you are
yes,
given then queries, and the queries will be of two types. First type
yes,
will be like you are changing any edge weight of any between any two edges, and the second
yes,
type of query is you have to find out the shortest path between the root node, that is 1, to that
yes,
particular x node. Okay, so like
yes,
in this example, this query 2 comma 1, it what sorry, this query 2 comma 3, so what is it suggesting? First of all, 2 means this is the second type of query, and
yes.
3 means you have to calculate the shortest
One,
path
two,
from 1 to 3, and
yes,
shortest path doesn't make any sense, as Ishan said in 3, so you have to just tell the path, the
yes,
distance between them. Yeah, now
yes.
you can continue.
So, yes, I think the question is clear, no? So the second thing here is now, here the edge weights are changing. Like the tree is not dynamic. Sorry, the tree is not static. The tree is continuously changing. So, if here there if the first query was not here, then we could have directly just like pre-computed the uh, distances by using DFS, and we could have easily done this. But here the edge weights are changing. So here comes the concept of segmentary and Euler tour. This is a very standard question. Uh, so I will explain short what is a Euler tour. Euler tour is basically a way to flatten the tree. Means basically segmentary is generally applied on linear data structures like array. I mean, so obviously only array. So tree is not a linear data structure, so we have to convert it into a linear data structure. And the way to do it is Euler tour, which is also called as flattening of the tree. For example, if you see this tree here, the Euler tour of this tree is given as 1, 2, 2, 3, 3, and 1. If you see it, it's just like the DFS call stack. First you go to 1, then go to 2, then exit from 2, then you go to 3, then again exit from 3, and you exit 1. So basically, in my Euler tour, each node appears two times. So you can say that the size of that flattening tree will be 2 into n. And the more, again, one most important observation is that if you see that the first and the last occurrence of any node, in between that there is a whole subtree of the tree, and that is obvious because we first travel the subtree and then we exit it, and this actually helps us to solve a lot of problems. Okay, then this is the segmentary template. I will not explain it. You can go and search on
Yes,
Google.
build
This is
and
the
update.
segmentary template. This is a standard segmentary template for calculating the range sum. Means you are given L and R, and you have to calculate the sum in between. And yes, uh, now let's see how I calculated the Euler tour.
Let's first start from here, this making
Yes, okay.
adjacency list.
First, I have constructed the adjacency list, uh, and this tour vector basically stores my Euler tour, and this timer, yes. Now when I have constructed the Euler tour of the tree, then I should also know the indexes at which my node is there. So to do that, I have to maintain another two vectors, in time and out
Hmm.
time. You can call that. It's not
Hmm.
any very new concept. It's like basically when we enter the node, at what time we enter the node in DFS. It's nothing but a simple recursive call stack. For example, in the left side of the example, you enter one at zero time, you enter again two at one time, you exit two at two time. So this is what tells me that means this basically helps us to identify where my two number node is in my Euler node. And here below it I've calculated the Euler node. This is just a simple lambda function where I'm doing the DFS. Now, one thing is that here I have been given edge weights. So, and obviously I want to construct a segment tree, and my flattening tree, that is Euler tool vector, will store the nodes, not the edges. So I have to here first convert the edges into the node weights. So if you see here in my DFS, I have taken the value vector, which basically in that basically I'm storing the node weights. For example, the edge weight between one and two is two, but I'm pushing two downwards. That is my two's node weight will be two. And here I have done this here value of it dot first equal to it dot second. This basically does that. I'm just handling the edge weights. I'm changing edge weights into node weights, and this basically simplifies me to use the segment tree. Now, uh,
Okay.
this in this way I can construct the segment tree, and after that, if you see that I've just updated the values. Yes. Now in here, if you see in time, I have taken the positive values, and at out time I have taken the negative values. This is because I have to calculate the path sum, and if I have to calculate the path sum, then I can DFS can go into another subtree, and then I will come to my desired path. But I
uh,
don't want that extra sum. So in order to cancel that effect, I'm taking negative values in my second out time, in
uh,
second appearance.
like just to add more to it, like if you have to calculate the distance between 1 and 3, then
Yes.
1 and 3, then obviously the edge weights of 2 will also come. But now if there is negative thing associated with the exit,
Yes.
then this 2 and 2 will get cancelled out from each other, and we will get the distance between 1 and 3. Yeah,
Yes.
now you can
This is
continue.
simple TFS. First, the recursion goes to left side and then comes to right side.
Yeah.
Okay. After that, I have just solved the queries here. The first, yes, first I have built the segment tree actually.
Yes.
The building segment tree is like take n
Yes,
log n
10 and format.
complexity,
Yeah.
and here in queries, like I
Yeah.
have updated. Now I told you before that I am converting the edge weights into node weights. So if there is a edge between U and V, then obviously the new WT weight, I will push it to V. So I
Correct.
have done here the same thing, in of V and out of V. At both places, I have to change the weight.
Yes, we are updating that.
That's what I've done here. And update takes the login complexity in segmentary.
Hmm.
And the second type of query is query. I'm just finding the range to sum and of the path, and this
And
is
pushing
in
it.
of one and in of v.
Huh.
And this is basically it's if it's difficult to imagine, you can draw a tree and check. It
Yes.
basically cancel out other subtrees, and
And
it will
just
give you
give
the
the distance
desired node.
between the 1 and V.
Yes, the
Yes.
desired node.
Yes. And we
And
are just pushing it in answer.
yes,
Yeah. Okay, so
the overall time complexity will be n log n for constructing the segment tree.
yes. Yes. So this is running fine. Okay. Thank you, Ishan, for
Yes.
the explanation. Yeah, so this was the contest discussion video of Biweekly 154. Thank you all for watching. Thank you, Ishan.